It's a Raspberry Pi from 1976. Kinda. This is what could be considered to be the Raspberry Pi of its day. A single board computer with everything you need to get up and running, all included. Even a display of sorts. And a display isn't something you see on a modern Raspberry Pi. In 1976, you could do all kinds of amazing things with your KIM 1. I don't have a comprehensive list, but I imagine back then they were all being used to control smart fridges and run Plex servers or such like. But all kidding aside, this machine is arguably where it all began. And I don't just mean hobby projects using new technology. No, this single board computer was created by MOS Technology to showcase its new CPU, the incredible 6502. Let's have a little history lesson. I'll need some special music for this. Nice. And some classy B-roll with blurry backgrounds. Check. In 1976, Chuck Peddle and a few other ex-Motorola employees went to work for MOS Technology, where they set about creating a CPU to satisfy a gap left in the market by Motorola's expensive and built for serious business applications 6800.
Hey, what's going on here then?
Nothing.
That's my music.
Is it? That must be a terrible coincidence.
And more importantly, my dining room. Lee, are you in my house?
Oh, this is a bit awkward. Quick, show him the KIM 1. Grab the camera, leg it.
Ooh, now that's a shiny looking KIM 1.
That should keep him busy for a while. Let's get back to my workshop. MOS Technology needed a way to get their new CPU into developers' hands, and the KIM 1, along with its sibling the TIM 1, are what they came up with. Although not initially intended for the home hobbyist, the KIM 1 took off in that market. It was so successful that the 6502 CPU ended up in many of the home computers that shaped the market for years to come. Ever heard of Apple? I think that's all the backstory we need right now, and I should really leave the entertaining history videos to people like John Retrobytes and get on with building stuff. This lovely matte green KIM 1 replica was given to me by the simply amazing Dave Williams of Devilish Designs. I was pleasantly surprised to see his name on this replica of the Apple I on a recent visit to the Cambridge Centre for Computing History. The first time I met Dave was actually in that very building where he was exhibiting at the Retro Computer Festival last November. I'll be going again to this year's event, as will Dave, so book a ticket and come and say hi. When Devilish Dave heard this year's More Fun Making It charity event was to be Commodore themed, Dave, being Dave, asked if I would like a KIM 1 replica kit for the auctions. Now, I have to admit, I didn't actually know what a KIM 1 was. I'd heard of it and seen it referred to in passing, but I needed to do a quick Google search to find out the KIM 1 is considered to be the first of the Commodore microcomputers. Soon after, MOS Technology settled a huge lawsuit brought by Motorola for copyright infringement. Their business fortunes, exacerbated by problems in the calculator markets, took a large dip, and they were snapped up by noted calculator makers Commodore. Not long after the success of the KIM 1, Commodore were to produce the PET, the first proper computer of their own making. And fear not, there will also be a PET in the charity auctions on the 19th of October. Sadly, it's not an original, as the cost and dangers attached to posting a fragile computer with a heavy CRT inside are too great to risk. But more on the PET in a future episode. Dave gave me a choice of colours for this donation. I could have either white, which did look fantastic, or purple. Well, you know what's coming now, don't you? No, not the calculator, although that was another amazing donation and will be in the auctions. He sent over not one, not two, not even three. I have here 4 replica KIM 1 motherboards in beautiful purple and gold. He also gave me one complete kit with which to build a set of these boards up into a fully fledged KIM 1 single board computer. To get myself warmed up before the main event, I'm going to build up this daughter board first. This connects to the KIM 1 and provides a way to easily attach a power supply, as well as an RS-232 serial interface and audio in and out for loading and saving to tape via the 3.5mm sockets. The parts are labelled on these handy paper envelopes, making this a pleasure to build. All of the resistors are clearly labelled with their colour codes to make finding the right ones a breeze. And the values are printed right on the silk screen, so it's hard to get this wrong. I've said before how much I appreciate this kind of effort. Let's bear that in mind for later, shall we? Soldering montage. There will be long stretches of these throughout this video. I want to show just about the whole process, and I've marked the chapters so you can skip ahead if you hate art. I don't know what it is about this LED, but it looks amazing. I asked Dave about it and he said he included it for me as a bonus that isn't normally included with the kits. It turns out this is a vintage LED, and when you see it later in the video, I hope you appreciate just how good it looks on this board. This foam contains all of the chips for this build, as well as the sockets and the 7-segment LED displays. This other LED is the standard one. I won't be using this, but it will find a new home in my parts bin. Transistors, which I have been told are not passive components. Thank you, YouTube commenters, for my continued education. And then a bunch more bits I soldered to the board whilst forgetting to lock my camera focus, so it's not that nice to watch in real time. Let's skip ahead to the good bit. This 9-pin eSub connector is for the RS-232 serial interface. The KIM-1 could natively talk to serial devices, for instance teletypers back in the day, but the protocol it uses is the old 20 mA standard, which is no longer common in this modern world. These days it's much easier to use RS-232, and this board gives you that interface. A couple of logic chips slot into their sockets, and all that's left now is the edge connector. I've done a few of these on ZX Spectrum peripheral builds and I quite like the process. First, it's a good idea to bend both rows of pins so they at least touch the contacts on the board. These ones are super stiff and it takes a few goes to get them bent to the right angle. The middle ones are not quite there, but that doesn't matter. I just need the board to hold its position while I anchor the end pads, making sure the board is straight and level. Then a squirt of flux and application of some super thick solder wire I keep just for jobs like this. I'm encouraging the solder to flow up the length of the pad and the pin to make as strong a joint as possible. Perfect. That's complete and looks good. Now we come to the main event. I need to get this to look like this, not the green. So what's left in the component list? I still have all of these lovely chips and sockets and the displays. This pack is labelled keypad, so I assume I need to do this last. All of the resistors, diodes, ceramic capacitors and transistors, along with a few extra bits, are in these brown envelopes and marked pack 1 to 4. So it looks like the thing to do here is open up pack 1 and start there. But wait, as gorgeous as this looks in purple and gold, there's something I'm used to seeing here and it's not here. Where's the silk screen? Well, this wasn't on the original, and this is meant to be a modern version of the original board. So there's no silk screen at all on this board. Instead, Dave has provided a map of sorts, a board layout diagram showing where the components go, with the parts list on the other side. Not only are the part locations missing, the markings for polarity are nowhere to be seen. I'm using a combination of the board layout sheet and the other green KIM 1 as a reference, although that causes me to run into problems later, as these boards are not the same. I'm having to check and double check where these go. Without the usual markings, all of these holes look very much the same, so I'm having to work out things as I go along. You will note that every resistor gold stripe is in the same orientation, either north or east, as is my preferred way. For this type of work, I've taken to using blue painter's tape to hold the components in place rather than blue tack. It's a bit easier to put on and off and works well for me. These heavier 1A diodes go into these larger holes, so they're nice and easy to get right. And whilst all of the components are at the same height, I can use the workbench to hold them in place. Clip off the legs, and then solder them. Two packs down, 3 and 4 are next. This row of resistor pairs govern the amount of power provided to the 7-segment LED displays. They are 1K and 200 ohms in each pair, and later on I'll have to swap these around, not because of error on my or Dave's part. He found swapping these around gave a better level of light, and on a further chat with him, it turns out the schematics he used to create the replica are wrong. I'm sure he'll fix this in future kits, which he sells occasionally. If you fancy building one of these amazing machines yourself, you can find a link to his eBay account in the description. I'm not short of blue tape, but it doesn't stop me reusing the same strips over and over again. Right, that's all of the brown envelopes done. Now we move on to pack 5 and its lovely collection of yellow polyester film axial capacitors. These are not polarised, so it doesn't matter which way around they go. But to keep things looking neat, I make sure the value is at the top where it can be seen, and the right way round according to the board orientation. This machine is not going inside a plastic case, so I can at least try to make it look pretty. There's also a couple of blue electrolytic axial caps, which are put aside for now. To keep with the system of installing the lowest components first, I need to fit a transistor I put aside earlier and almost forgot about. Here is Benchley to explain what's going on here.
I nearly forgot that transistor, which is Q7 on here, and on here it shows the flat side at the bottom, so we'll go that way around on here, which makes sense. But I have been checking the components against the board that Dave gave me, and I see that the transistor here, which is a BC337 or 338, BC338, is the other way around. So I wasn't sure whether whether this was right or the schematic was right. So I checked the schematics online for the KIM1, and the collector, which is pin 1 on this transistor, which is, if the flat side is facing me, it's the one over that side. So the collector should be connected to R17, and R17 is here. It's this side, so that's the collector. So that's pin 1 goes over on the left hand side. So the one in the board that Dave gave me is in the wrong way around. Dave, what did you do? I'll double check with him just in case, because you never know. But I'm pretty sure that's right.
I did check with Dave, and he explained that the green board is an earlier revision where he may have made a few tiny mistakes, and this transistor may have been one of them. On with the caps. The legs on these are super long, and I want them to all look uniform, so I'm bending them by eye to get them to sit in the middle of their positions as accurately as I can. This one here has managed to slip a little out of line. That's fine, it doesn't need to be millimetre accurate, as long as it looks good. And here is one of those mistakes which I'm blaming squarely on the lack of silkscreen. Benchley.
Oh, something else I've got wrong. Looking at the board that Dave gave me, these aren't exactly the same. This is a revision 1.1. and this is a revision 1.3, if you can see that. I did wonder when I put these diodes in here that I thought that the cathode was at the wrong end on this one, and it turns out that this one's wrong as well, because this one is supposed to be in this position and this one's supposed to be where that one is. So I need to change those. Just heating up my desoldering station, and I'll whip those out and just move them up one. It's quite difficult without silkscreen.
Oh, stop your whining. Okay, that's better. Let's get on with those caps. more components I fit to the board, the easier it gets to find where each one goes. It really has been a fun and unique build. The last caps are the electrolytics. These do have polarity, and I have the green KIM 1 and the board layout next to me on the bench to make sure I don't put these in the wrong way round. Sockets are next, and it's time to get my blue tack out again. Even with the blue goo holding the sockets in place, I still go through the process of soldering a couple of the pins in diagonally opposite corners and then reflowing them whilst pushing the sockets flat on the other side, being careful not to burn my fingers too often. Going to fit 3 sockets at once here, so some extra blue tack is required. It's amazing how long I can make this stuff last. It's not expensive either. And another mistake, this time because I wasn't paying attention. I assumed all of the sockets were in the same orientation, but turns out they're not. Luckily, I only soldered a few pins, so it's an easy job to pop these back out. Also, desoldering on these gold Enig boards is a joy. There we go, back in the right way round. Okay, I might be getting a bit overconfident here. 5 sockets at once held in with the blue tack. And 6! What could possibly go wrong? I don't recall ever soldering 7-segment displays before, so this is new to me. In any case, the pins on the base of these are not symmetrical, which implies there is a correct orientation. On the front there are 2 dots which might be decimal places on one side, and it would be fair to assume these are supposed to be on the right side of the numerical display. I sent out a plea for help to my build mentor, and Benchley.
I spoke to Dave and he said, well, if you look at the 7-segment displays on here, there's a dot on this side, and the orientation of the pins on the other side has this gap of 3 pins on the left hand side of the device and a gap of 1 pin up here on this side. I can show you that. I'm just going to flip this board straight over. So the 3 are here and the 1 is there. So it's like that. And that means that the dots are actually on the left hand side, so they have to go that way around, which is weird. But the good thing is that the Kim one doesn't even use the dots, so it doesn't really matter. Anyway, I just have to get the pins in the right place, otherwise I'll probably blow up all of the LEDs. So let's do that.
You blow stuff up? Never. The final part before the keypad is this large variable resistor. There's instructions included with the kit to show how to tweak this component to tune the audio circuit to make that work properly. I will tell you now that when I did this off camera later on, it was a huge pain and super sensitive. Keypad time. First there's a switch that controls if the machine is in free running mode or single step mode, where it steps through the code 1 byte at a time. Blue switches, not cherry blue, just blue coloured. They are authentically terrible. The legs on these grip the holes, so no need to hold them in place with tape or tack. And keycaps, black plastic ones. Not much to say about these really. And the last job is to put all of the chips in the sockets. Before I do that, I've connected up the power and I'll check it's getting to the right places on the board. Saves blowing up all the chips if I've put something in the wrong way round. Excellent, that all seems to be working correctly. Right, chips. And that's it complete. Doesn't it look lovely? This board will never be inside a case, so to save shorting things out, there are some feet to stick to the other side. The machine will run with 5 volts only, and only requires 12 volts to load from tape. But while I have my Pico ATX here, I connect up a ground, 5 volts and 12 volts for a full test. Fingers crossed. The LED is lit, and pressing reset, and nothing blew up. Pressing reset on the keypad shows there are signs of life. Under my filming lights it's quite hard to see the display, and as we discovered later, this could be fixed by swapping the pairs of resistors. For now I can turn down my lights so you can see what's going on. To test loading a program, I've connected up an audio lead to the line in on my bench PC. I need to set the Kim one up to get it ready to accept a program by entering some data into certain addresses. To do this I press AD, which puts the input into address mode, and enter the first address, which is 00F1. Then press the DA button, which is data mode, and enter 00. This changes the data held at 00F1 to 00. I do the same for 17F9. Then go to address 1873 and press the go button. I press play on the audio file on my PC and wait for it to load. It doesn't actually take too long, being less than 1K in length. Most programs on the Kim one I've tried so far start when you go to address 0200 and press the go button. I've chosen to play Asteroids as a test. The 0 key moves left and 3 moves right. The flashing line is my ship, and the solid lines falling down are the asteroids which I must avoid. It's actually a great little game, and I can't imagine how this would have felt to play in your own home back in the 1970s. Imagine spending a quiet hour entering this program from a listing, patiently saving it to tape, and then running it. All this before your black and white TV could even watch Blake 7. I had a great time playing with this in its standard form, but there is more you can do. For a start, you can connect it to a serial interface where you can use a real keyboard and a screen. So in a follow-up episode, I'll be building one of these marvellous Versaterminus boards sent to me by the brilliant Julian of the Board Folk. Those guys get everywhere. I'll explain more about that board in the upcoming episode, but I can say this is a special edition that Julian created for the charity event. Also in that episode, I'll be expanding the Kim 1's 1K of memory with an upgrade that Devilish Designs Dave, or Triple D as I'll now be calling him, is sending over soon. These two things will allow me to play chess against the Kim 1 on a screen, something I'm really looking forward to. Not that I'm any good at chess. And soon after that, on the 19th of October, I'll be selling this Kim 1 with the upcoming expansion and the serial board to raise money for the befriending scheme. On that day, there will be every Commodore microcomputer, apart from the Macs, I'm not made of money, from this Kim 1 all the way up to the Amiga 1200. All of them, not the Macs, for sale in the charity auctions, and some of them in multiples. There will also be a load of other bits and pieces for sale, such as the Commodore calculator you saw earlier in this video. I have 3 of those to sell, and books, software, peripherals, all sorts. I'm doing my best to get things organised, so as much of the stuff that has been donated as possible will be ready to sell on the day. But due to the sheer generosity of all of you lot, the chances are high there will be some slippage, and some of it will just have to go in a second or even a third sale. Whatever happens, I'll be running a 12-hour live stream joined by loads of special guests from all around the world of vintage tech and retro gaming YouTube. Some of the guests will also have great items they're selling at the same time, and all of the proceeds will go to the befriending scheme to raise money to buy some miniature donkeys to live on the Red Rose Community Farm. We need to raise £15,000 to meet the target, and I really think we can do it. Last year, I was totally blown away by the amazing generosity of everyone that donated to the cause, and I'm hoping we can match the amount raised then. If you are able to donate even a small amount, please go to the Just Giving page, which you can find linked near the top of the video description, or linked on my website, morefunmakingit.co.uk. Share this video far and wide so we can get the word out there. Good luck, everyone. Bye.